The image you see here perfectly captures our central argument. Music is not a language, it is a city. For years, we have celebrated the incredible achievements of machines that master human language, training them to process text as a sequence, one word following another in a neat, predictable line. But music fundamentally defies this linear logic. Think about it. When you listen to a great piece, you aren't just hearing one stream of information. You are immersed in a polyphonic metropolis of sound. You have multiple streams of notes, complex harmonies, and layered rhythms all playing simultaneously. It's an intricately interwoven tapestry of sound moving through time, where a guitarist's rapid flurry of notes can be set against a pianist's deep, sustained chord, and a drummer's complex beat ties it all together. This massive, simultaneous complexity is the fundamental challenge. We have figured out how to teach a machine to speak, to manage a linear sequence, but the true frontier, the great leap forward in generative AI, is to teach a machine not merely to speak, but to build an entire world of sound, a truly three-dimensional sonic architecture that respects the simultaneous nature of musical art. This complexity is why the architectural metaphors are so apt, and it sets the stage for the two monumental approaches we will explore today. To conquer the immense, nonlinear complexity of musical creation, two fundamentally rival philosophies, two titans, have emerged from the silence of our digital labs. These are more than just different algorithms or code bases. They represent competing worldviews on the very nature of art, creation, and order itself. On the one hand, we have the philosophy of the logician, the architect. As shown by the hand drawing the blueprint, this approach seeks to deconstruct the musical city brick by brick. It believes that true mastery comes from learning the specific, sequential logic of every component. If you can understand every note, every duration, and every rule of voice leading, you can reconstruct the entire masterpiece. It is an act of painstaking analysis and deduction, striving for technical perfection. Conversely, we have the philosophy of the forger, the dreamer, represented by the chaotic, yet vibrant, splash of paint. This titan seeks to bypass the sequential analysis entirely. Its goal is to dream the entire city of sound into existence at once, generating a complete, holistic canvas of harmony and rhythm in a single, audacious stroke. It deals in intuition, synthesis, and deception, rather than linear prediction, focusing on immediate, complete artistic vision. The tension between these two giants, the logician focused on logic and the forger focused on intuition, defines the frontier of generative music today. Our first titan, the logician, is embodied by the architecture known as the transformer. This model fundamentally approaches music as an encrypted language, a dense sequence of information that must be decrypted and predicted sequentially. The logician believes that by meticulously breaking a complex musical composition down into its absolute fundamental components' individual notes, their specific pitches, and their precise durations, it can learn the deep, underlying grammar of musical structure. It does not treat a Beethoven symphony as a single, holistic piece of art. Instead, it sees it as a long chain of discrete events, each waiting to be predicted in order. The fundamental unit it works with is the token. Imagine a familiar piece like a Chopin nocturne. The transformer doesn't hear the haunting, romantic melody in the way a human does. Instead, it reads a stream of specific data tokens, such as E5 0.5, meaning an E in the fifth octave held for a half beat, followed by G'5 0, 25, and then B5 0, 25. Its entire objective, its gambit, is simply to predict the next token in this lengthy chain. This is a task of intense, sequential prediction, building the final majestic piece of music one tiny, painful note at a time, strictly adhering to the logical flow it has learned from thousands of prior sequences. This method is exhaustive, demanding precise calculation at every step to ensure continuity and structural integrity. The key innovation that makes the logician's sequential approach viable for complex, long-form music is the power of the attention mechanism. A human composer, when writing a fugue or a sonata, constantly builds upon motifs and harmonic ideas introduced minutes, or even pages, earlier. Older neural networks, like recurrent networks, had a significant short-term memory problem, where the relevance of previous information faded rapidly with distance. They would often forget the established key signature or the primary thematic fragment introduced 50 notes ago. The transformer overcomes this fatal flaw decisively. The attention mechanism allows the model to look back across the entire sequence it has generated so far without diminishing the weight of older events. Critically, it doesn't treat all previous notes equally. Instead, when deciding on the next note, it calculates and weighs the importance of every single previous clue in the sequence. For example, if it introduced a major theme several measures ago, the attention mechanism ensures that the subsequent note choice remains strongly connected to that thematic fragment. This ability to maintain long-term structural coherence is absolutely vital for musical composition. It's how the transformer remembers the established key signature across a complex passage, and how it successfully repeats a motif, not just identically, but with necessary and meaningful variation, ensuring the resulting composition possesses genuine structure and logic across long passages of time. The fundamental challenge for the logician is reconciling the multidimensional world of polyphony with its own linear, sequential nature. Music is almost never a single melodic line. It involves multiple instruments, or tracks, playing simultaneously. So, how exactly does a sequential model force this complex multi-track soundscape onto a single, linear track? The answer lies in tokenization, and two primary methods exist to flatten the score. The first is grid tokenization. This method flattens the entire score into what is often called a piano roll. It reads one vertical slice of time, one time step at a time, across all instruments simultaneously, before moving neatly to the next slice of time. For example, one token might represent the simultaneous sounding of a soprano C4, alto E3, tenor G3, and bass C2. While this is systematic and highly organized, its rigidity is a major drawback, as it tends to lose the subtle nuance of note duration, especially when instruments don't align perfectly on a grid. The second, more flexible method is event-based tokenization. This treats the music as a literal recipe of sequential events. No-to-en, C4, followed immediately by no-to-en, E3, then time shift, 0.25 to introduce a pause, and finally no-toff, C4. This is far more expressive and allows for greater rhythmic complexity, capturing nuance better than the rigid grid. However, it comes at a significant cost. It dramatically increases the length and complexity of the sequence the model must learn and predict, making the task for the logician much more computationally intensive. Now we turn to the second titan, the forger, embodied by the MuseGAN architecture, which completely scoffs at the logician's idea of linear prediction. The forger views music not as a sequence of discrete events, but as a singular, holistic canvas, an image to be forged. It utilizes the concept of the piano roll, where time stretches along the x-axis and pitch runs vertically along the y-axis, allowing a musical passage to be visualized as a single block image. The crucial distinction is this: the forger does not laboriously predict the next note in a chain, which can take enormous computational effort. Instead, it generates an entire painting of a musical passage, perhaps a complete two-bar segment across multiple tracks, in a single, audacious, holistic act. This means it creates harmony and rhythm simultaneously, rather than sequentially. This approach is rooted not in logical, sequential deduction, but in intuition, synthesis, and deception, which is the core mechanism of its training. Consider the immense complexity of a Beethoven string quartet, where four distinct, interwoven voices must interact harmonically and rhythmically without clashing. The MuseGAN doesn't attempt to untangle these voices into four separate sequential tracks. Instead, it generates the full two-bar image containing all four parts at once, immediately capturing their dense harmonic and rhythmic interplay in a single stroke, making it a powerful engine for dense, polyphonic creation. The forger's power comes from a specific type of machine learning framework known as the Generative Adversarial Network, or GAN. This is not a lone creator, but an endless duel, a crucible where art is refined through relentless critique. The system consists of two primary networks locked in competition. First, we have the generator, which we call the forger. This neural network starts by taking random noise and converting it into a new musical painting or two-bar segment. Its sole, singular objective is to create a forgery so convincing, so structurally sound and stylistically authentic, that it can successfully pass for a piece of real music composed by a human. Second, we have the critic, or the inquisitor. This is a separate neural network, which has been trained extensively on thousands of examples of authentic musical compositions by human masters. Its job is purely adversarial. It must relentlessly distinguish the generator's forgeries from the real music, acting as a quality filter and gatekeeper that demands ever-increasing sophistication. This endless, high-stakes battle forces the generator to move far beyond superficial mimicry. To consistently fool the highly discerning critic, the generator must learn the deep, intricate underlying structures of harmony, rhythm, voice leading, and overall style, creating works that truly capture the essence of the musical tradition it is attempting to replicate, rather than just sounding random or chaotic. One of the most significant practical advantages of the Forger's image-based approach is the granular, high-level control it offers to the creator, giving it a compositional edge over the logician. Unlike the transformer, which can feel like a black box where one-note prediction influences all subsequent steps, MuseGAN explicitly separates the different aspects of the music. It doesn't start with one random noise vector, but with 4 distinct vectors, allowing a composer to truly direct the art by pulling the strings of the composition. These 4 vectors control the core elements. First, chords control the global harmonic progression over time, acting as the fundamental musical foundation shared across all instrument tracks. Second, style is a global vector that defines the overall aesthetic, such as genre, complexity, or mood, affecting all bars and tracks consistently. Third, melody is a unique vector assigned to each track, crucial for generating independent melodic lines and developmental ideas. Finally, groove is also a track-specific vector that controls the precise rhythmic character and feel of that specific instrument across the passage. By manipulating these 4 independent inputs, a user gains unprecedented flexibility. For instance, you can radically change the harmonic progression of the piece by altering the chord vector without touching the rhythm, or you can adjust one instrument's melodic line while ensuring all the other rhythmic and harmonic elements remain perfectly consistent, offering true artistic direction. To understand how the Forger successfully creates its masterpiece, we must look at the specific anatomy of its process, which unfolds in 3 highly structured steps. In step 1, the 2 evolving vectors, chords, and melody are first passed through specialized temporal networks. The crucial purpose of these networks is to take the initial, static noise vector and stretch it across the specified number of bars, allowing the model to learn precisely how harmony and melody should evolve and develop over time, ensuring they don't remain static or repetitive. These temporal networks provide the dynamism required for compelling music. In step 2, we have the critical phase of concatenation. To generate the specific musical content for just one single bar and one single instrument track, the relevant outputs from all 4 components, the temporal chords, the temporal melody for that track, the global style, and the track-specific groove are all combined and merged into a single, cohesive, and information-rich long vector. Finally, in step 3, this combined vector is fed directly into a track-specific bar generator. This generator is typically a convolutional network, which is highly effective at working with image-like data. It takes the abstract vector and expands it out into the final 2-dimensional piano roll image, representing the notes, pitches, and durations for that specific bar and track. This entire structure is ingeniously designed to ensure structural integrity. The global style and the rhythmic groove remain consistent throughout the piece, providing a unifying framework, while the chords and the specific melody lines are free to change and progress dynamically from one bar to the next, creating a coherent, developing composition that is greater than the sum of its parts. When the Logician and the Forger are set loose, the art they produce is as distinct and unique as their methodologies. We are not asking which model is inherently better, but rather observing the nature and quality of the musical art that each intelligence creates. The transformer, the Logician, excels at generating works that are structurally sound, harmonically logical, and maintain impressive coherence over very long passages of music. Because it works sequentially, predicting one note based on the grammar of the previous notes, it naturally excels at difficult tasks like smooth voice leading and strictly adhering to the established rules of a specific style, such as classical counterpoint. It is the master of technical fidelity. However, Its weakness lies in its constrained, linear nature. High-level control is notoriously difficult. If you want to change the overall mood or the harmonic direction halfway through, you often have to regenerate the entire piece from scratch. Conversely, the MuseGAN, the Forger, generates compositions that are immediately holistically coherent, atmospheric, and often rhythmically captivating because it creates the whole bar at once. Its defining characteristic is its superior high-level controllability over style, groove, and harmony, offering great flexibility. But because it prioritizes the holistic image over the strict sequential chain, it can occasionally lack the intricate, note-by-note sequential perfection and perfectly varied harmonization that the Logician achieves, sometimes missing the subtle detail a master human composer would include in fine inner voices. The epic conflict we have witnessed today between sequence and image, between rigorous logic and audacious intuition, has not produced a victor. Instead, this creative tension has unleashed two profoundly new and powerful forces into the world of musical creation. These aren't just mere tools designed to replace human composers. They are alien intelligences, each offering a fundamentally different and valuable way of understanding and generating art. The Logician, the transformer, brings to the table structural perfection, ensuring long-term coherence, impeccable voice leading, and adherence to the grammatical rules of music. It provides the solid, logical architecture. The Forger, the MuseGAN, brings holistic control and atmospheric intuition, allowing the creator to paint vast sonic landscapes with ease, dictating the mood, style, and harmony on a large scale. The most exciting outcome is the realization that these two titans are destined to become collaborators. Imagine a future system where the MuseGAN sketches the overall harmonic and rhythmic framework, a large-scale artistic vision, and the transformer steps in to refine the fine-grained, note-by-note details and perfect the voice leading across multiple tracks. The music of the future, therefore, will likely not be written by human or machine alone, but will emerge fully formed from the fertile, creative tension between the Logician, who ensures structural soundness, and the Forger, who provides the visionary scope and holistic control.